Welcome again to Basecamp 8. This is the third session, and today we are going to focus in exclusively on Cairo. In this case, actually Vanilla Cairo, because as you know, you can use Cairo on its own, and also you can use Cairo to write smart contracts on a Starknet. That's going to be the focus of session 4, the last session next week. Today is just Cairo on its own. So as I mentioned, this is the third session. Session 1 was fundamentals. Session 2 last week was deep dive. Today's Cairo. Next week it's going to be Starknet. Session 3 and 4 is going to be all mostly live coding. Now, topics covered today, a little bit about what actually Cairo mean and its history. We touch points on what field elements are and what's important to be aware of them in Cairo. Then a little intro to Starklings, which is going to be the focus of today's session, talking about what's going to be the homework for today. And then we actually move to do some live coding, not only to solve Starklings, but also to install dependencies for any of you that haven't yet set up your dev environment for Cairo. Now, Cairo, it's actually a confusing name because it actually has multiple different meanings. So far, when we talk about Cairo, we mostly talk about the language, but the original name Cairo it was a reference to a new type of computer architecture that is fine-tuned for validity proof. And this computer architecture is known as the CPU AIR, and AIR means algebraic intermediate representation. So the original meaning was a computer architecture based on polynomial constraints. Then the low-level bytecode executed by this CPU AIR, by this new CPU architecture, which is the heart of the Cairo VM, is known as the Cairo assembly, or CASM for short. Right? There's another reference to Cairo, the term Cairo assembly. Now, the high-level language that compiles to Sierra and then compiles to Cairo assembly is also known as Cairo. And this is what so far, when we talk about Cairo, this is what we refer to. But keep in mind that its original was about the architecture of the computer. The old implementation of the high-level language is known as Cairo 0. It's known today as Cairo 0. Obviously, when the first version of Cairo came out, it was just known as Cairo. But then, I believe it was last year, there was a big change to the language, to the syntax. So to make a distinction between the old version of Cairo, the old syntax, and the new one, we call the old one Cairo 0, and we call the modern one just Cairo. Paul is asking, what is Sierra? So Sierra is an intermediate representation, and the goal of Sierra is that it allows the sequencer to generate what's called safe Cairo assembly, which is able to handle failed transactions in a way that is safe for the system, right? So you can actually have reverted transactions thanks to that. Before Sierra, we didn't have a way to guarantee that failed transactions can actually be safely reverted, and the sequencer compensated for the work up until the point that it failed. Now, obviously, Cairo is also the capital of Egypt. So trying to search for the word Cairo and hoping to get, as a result, something connected to Starknet is almost impossible, right? You have to be very specific about what you're looking for. So it's not good for search engine optimization. So in 2018, that's when the Stark white paper actually was published. And Stark is the ZK proof that underpins all these technologies, Starknet, Cairo. And just 2018, that's like 5 years ago. You have the link here to the white paper if you want to take a look at it. Now, in 2019, that's when Starkware created StarkX. We briefly talked about the StarkX in session 1, which is something similar to, it's like a permissioned version of the ZK technology. That is what used by DYDX, by MetableX, and so on. The original version of a StarkX, it actually had hard-coded polynomial constraints. Right? Back then, there was no Cairo. It was just basically by hand. And that was actually feasible because a StarkX only has a limited number of things that it can do, like trading, spot, options, stuff like that. So it's feasible to actually hard code those things and just make it work. But Cairo came to need, okay, how can we actually build more features into something like StarkX without having to manually write all these polynomial constraints? So that's what in 2020, actually, Cairo was invented. That initial version of Cairo is what we call today Cairo 0. And the first goal of that version of Cairo was actually to help StarkX to be more flexible in what it could offer. Douglas Url is asking, is DYDX L2 is still up and running. Yeah, so DYDX v3, I believe, is still up and running because you can actually, if you go to L2 bit, you should be able to see it still here. DYDX. There you go. DYDX v3. That is the one I think still associated with the StarkX. DYDX v4 is the one that is actually being built on top of the Cosmos ecosystem. So it was only the year after, in 2021, the white paper describing Cairo, in this case, not only the language, but the new CPU architecture, the Cairo VM, was actually published. And it was the same year that actually was implemented on Starknet, right? So now, actually, Starknet, the mainnet, started in 2021 with Cairo directly. And that was the first time you could use Cairo to write smart contracts. In 2023, last year, that's when the big change to the language actually happened. The release of Cairo 1, which is like, we just call it Cairo, the modern Cairo, the one that you're learning today. And it was a very big change in how the language looks like, how it operates. And actually, it's a much higher language than it used to be. So much more easier to work with as a developer. I like to think that the connection between Cairo and Starknet is the same as Python and Django. You can use Cairo to write general purpose programming languages, general purpose programs, but also you can use Cairo to write smart contracts for Starknet just by using the special syscalls and special attributes as macros. The same way that you can use Python on its own to create scripts, or you can use it to write, like a static website using Django. Django is, at the end, is just Python with just extra libraries specialized for static websites. One thing that is new to Cairo, which is very different from, for example, Solidity, is the concept of the field elements, or felt. So felt is the default data type of Cairo, right? And the full name is felt 252, right? In the sense that this variable requires 252 bits for storage. And this is an important comparison to Solidity, because Solidity, the default data type is U256, right? So you can see here that it's, first of all, a little bit smaller, and it's a field element. It has some interesting properties. So in a single variable that is a felt, you can store values between 0 and p being a large prime number. And this is coming from all Starks, how Starks work. It's a requirement. And this prime number is very large. You can see the exact number is on here, which is smaller than 2 to the power 252, right? It's not exactly as you will think normally. In the case of U256, you expect the largest number to be 2 to the power of 256. No, here the largest number is a prime number that can be stored in 252 bits. Another property of a field is that all operations, all mathematical operations are actually mod p, which means that a field can overflow and can also underflow, right? So if you store the maximum value, like this prime number in a field, and you add 1, then you wrap around and go back to 0. And the same is true if you go back from 0 to a negative number. You wrap around to the end of the field, which is something to keep in mind, because that is not what you want in a smart contract, right? You don't want your balance to overflow without you knowing, or without an error being raised. Also, because of it's a field, division or integer division works in a different way, and sometimes it's very surprising the result you get. For example, if you divide 1 by 2, the result that you get, if those two variables are felt, is not 0 or 0.5. It's actually p plus 1 divided by 2, which is a very large number. Now, this is not an error of the system. This is how fields actually work. But again, it's not probably what you would like to see as a result, right? So it will be confusing that you do 1 divided by 2 and you get a large number. Like, what is it coming from? So that's the math of field elements. So of course, that will be confusing for you as a developer. So Cairo also supports signed and unsigned integers that actually solve both of these issues. An unsigned integer and a signed integer, actually, they don't have issues with overflowing. If you try to add more than it can hold, it actually will stop the execution with an error, or the same with the underflow. And also integer division works the way that you will normally expect. This is all the different type of unsigned integers that Starknet and Cairo supports, like could be 8-bit, 16, 32, 64, 128, even 256. And then you have usize, which is pretty much defaults to U32 as well. So signed integers, they exist in Cairo, so you can use them if you're just running Vanilla Cairo, but it's not yet supported on Starknet. Right? On Starknet, only unsigned integers are supported, alongside with things like, for example, the strings. Now, any questions about field elements? There's a lot here in nuances. If you really want to know the details, I suggest you to actually take a look at the Cairo white paper, and also just research field elements, right? And some of the path. Now, the focus of today is to learn Cairo by solving Starklings. And Starklings is an interactive tutorial to learn Cairo. Here's the link to find the project on GitHub. It was created by Shrami, which is the guy you see here in the picture, and is currently maintained by the community. You can see it in only DOS, but you also, if you find there's some limitations, some issues with the tutorial, you can just go and submit a PR and just fix it yourself. It's written in Rust and it's inspired by Rustlings. Now, Rust is required to compile Starklings, right? The tutorial. But just keep in mind that Rust is not required to compile Cairo. So today we're going to install Rust just because we want to use Starklings. But don't get confused that you actually need Rust to execute Cairo. You don't. Douglas is asking, as an application developer that doesn't know ZK proof, is there a case where I need to use felts? Is there a case you need to? The only place where you really use felts indirectly is when you have contract addresses, because there's a custom type called contract address. But if you see the definition, it's just a single felt, right? Because you want to use the maximum amount of storage possible. That is the only place that actually you will use it. But again, that will be indirectly because the type is contract address, not directly felt. So no, I will say that there's no reason for you to really use felts. Just stick to unsigned integers. You'll be fine. Just keep in mind that if you want to default to using U256, as in the case of Solidity, you will be using more than one felt to store that value. So maybe something to think about performance. So you really need 256 bits for storage, because if you don't, go one level below 128 or 64. So you don't use as much memory in your smart contract. It will be a little cheaper, but that's overall, you don't have to think about felts at all. But they exist. If you don't define the type of a variable, it will default to felt 252. Now, the live coding for today, we're going to first install Rust, then we're going to clone Starklings locally, and then we're going to compile the project. Because I'm using VS Code, I'm also going to install the VS Code extension on my computer. And then I'm going to install Scarp just because for the syntax highlighted to work correctly and to find the right binary, you actually need to have Scarp. And Scarp is something good to have anyway, because it's the main, it's a package manager for Cairo. So it's good to have it now because we're going to use it extensively also in session 4. And then we're going to add a specific configuration file for Scarp called scarp.toml. That is basically going to say which version of Cairo we want to use in the project. And then we're going to solve live half of Starklings, or maybe less. The idea is that your homework is to solve the rest on your own. So talking about the homework, obviously we do a little bit of Starklings here, but there's a lot. So the goal for you is to complete it on your own. And that'll be the homework not only for this session, but also for session 4, because Starklings covers not only Vanilla Cairo, but also covers Starknet. So keep in mind that the homework for today is just to solve all the exercise except the exercise connected to Starknet. Those are the homework for session 4. And once you solve it, make sure you publish your results or the project as a public repository under your GitHub username, the same GitHub username that you gave us when you registered to Basecamp, and to use this forum. So we know where you published the repository, and we actually can assess that you actually completed the requirement, because I'm taking that into consideration for graduation. So in this form is very simple. It's basically just capturing, give us the email that you used to register to Basecamp and what is the GitHub repository. But again, you don't have to give it for this session, because you can just wait until Basecamp ends, because the idea is that you complete all the exercises, including the one for Starknet, right? So you have the link in the slides to the form, but I'm gonna put the link here directly as well. Homework, the chat, if you want, you have it there as well. And that's it, I believe. So now I can actually switch to have a virtual machine ready to go. So as I mentioned, the first step, because first of all, let's find Starklings on GitHub so we can take a look at some of the requirements. So I'll search for Starklings, Starknet, and this one, Shrami, Starlings Cairo 1. That's the repository we're going to be working today. Okay, it's loading. Let me increase the font size, right? And put the link in the chat. Starlings, there you go. And we need to install first Rust, as it says here. So we can actually do it through Rust up. I'm just gonna copy this command. Just right, proceed with installation. That is gonna install Rust on my computer. So it's gonna install Rust up, which is the manager, then to install Rust, the compiler. The link of the slides is in the chat, Eric. Just go up a little bit. You're gonna find the slides link there. All right. So we have Rust's compiler. You just need to close the terminal and open it again. So let's verify that we actually have it. See, it's Rust C version. There you go. We have the Rust compiler. All right. Next step will be to actually clone Starklings in our computer, so we can start working on it. So I'm just gonna keep the repository. Let's clone it. Git clone. I'm just gonna call it Starklings, right? I get into the project folder. And now we need to compile this because Starklings was written in Rust. Okay, even though it's a tutorial for Cairo, the tutorial itself is written in Rust. So we need to compile it in order to use it. And to compile it, we have here in the structure of the README, we need to run this command, cargo run in Starklings, copy, go back to the terminal, clear it here, and then go for it, right? This is gonna compile Starklings. It might take a while, so while it's doing this, we should maybe take the time to install the VS Code extension for Cairo. So just gonna minimize this terminal, go back to VS Code. So if I go to the extensions, you can search for Cairo, and notice that we have two different extensions, right? Both by Starkware Industries. So this Cairo is for is Cairo 0, the old version of Cairo. So don't install that one unless you really need that one for whatever reason. One reason could be is because you want to use the Stone Prover, right? We haven't talked much about that, but the prover itself is open source, but currently it only supports Cairo 0, the old Cairo. It doesn't support yet Cairo 1. But for our tutorial today, we just want to use the modern version of Cairo. So we're going to install this one, Cairo 1. Okay, it's installing. Right, it's installed. So now we also need to install Scarp, which is Scarp is Cairo's package manager, which is cool because, for example, in Solidity, we don't have a package manager to handle dependencies. We do have it for Cairo. So we can actually go for it and just search for Scarp, Starknet. And this one is by software mention. And we're going to install it via ASDF. ASDF allows to handle multiple versions, not only of Scarp, but other global dependencies, like even, for example, Node.js, or for example, a Starknet Foundry, if you want to do some testing. Marshall asking, where do we get Visual Studio on Mac? It's free. You can go to the VS Code website and you can get it there for free for Mac, for Unix, and Windows. So I'm going to install ASDF. Reference race installation guide, maybe. Right. All right. So ASDF, I'll install it. Here we have. We run this filter and custom build command opens SSL. I have some issue with the compilation. Let me just update the pin. That's gonna solve the issue, and I'm gonna try to run again. Did any of you get this error when you try to install it? Some people are just waiting. Jordan said I'm not yet. So, okay, if it's running for you still, that's fine. I have it on my Mac as well. This is just a virtual machine. So if for some reason doesn't work here, I just can just go back to my home OS and just continue working there on the VM, outside of the VM. Marshall asking, are you supposed to be doing this at the same time? If you want only, but I just want to make sure that it's recorded so all the steps are documented so you can go back to recording and see the whole process. It's updated, so let me just try to rebuild the project. No, look at compiling on Linux and also target in Linux. So we need to install this package apparently. See, so the install, is it? Forgot the command. All right, let's try again. Hopefully that's all we needed. Oh, so we also need this package. This is a new requirement. I didn't have this issue before. Let me try again. Let's install this package. The install package. Let's try again. Compile Starlings. All right. At least we were able to get past that blocker. All right. In the meantime, I'm gonna open a new terminal because I want to install ASDF. Or did I? I don't know if I run it or not. Maybe not. Okay, let's copy this command. So that is installed apparently. Let's take a look. All right. So to activate the autocomplete into load all the environment variables required, I actually have all my C shell on my system. So maybe I'm gonna just modify, just gonna add ASDF as a plugin. You can find the instructions here. If you have, depending on your configuration of the system, if you have, I have a CSH and Git. So in my case, I just need to enable this ASDF plugin. Should be pretty straightforward. CSH. So in my configuration file, I just need to go to the plugins section, just add ASDF. That is if you have on my C shell. So if I close it, I close this terminal and try again. Hopefully we should be able to see ASDF installed. Yes. So we have ASDF installed. And ASDF is another package manager to install global dependencies. And we can use it to install Scarp. So we can do, you go back to ASDF plugin, add Scarp, and just following the, oops, copy the whole thing. Let's go step by step. ASDF plugin, add Scarp. Then we do ASDF install Scarp latest. In 2.5 is the latest one. So now I'm going to set that one as to be my global version. Global Scarp latest. So if I do now Scarp version, I have 2.5 installed and available globally. It's good. Let's take a look at our compilation. Still progressing. Paul is asking what VS Code extension we need to install. So the Cairo 1.0 extension is show you here. I should have it installed. This one here, Cairo 1.0 from Starknet Industries. You can search for it just here. Nestor is asking that it has an error. The request has failed. Yes, that error that you see in there from the because you actually need to have Scarp as well, because the issue that the extension doesn't know where to find the binary for that Cairo version that you want to use. And through Scarp, you actually can define where to find that binary. I'm going to show you how. But make sure that you have Scarp in your system, which I have here, right? Scarp 2.5.0. Now it's getting close to finish the installation. Nestor, if you have a Scarp, then what you need is to add to the root folder of Starklings. You're gonna need to add a scarp.toml file, which is what I'm gonna do once I manage to compile this project. But if you go to the Scarp documentation, a new package, you need to have this file, right? You can just create it by hand, scarp.toml, put that information in the file, and maybe just replace the name of the package with just put the Starklings. And when you restart the VS Code, you will know that it's going to be able to find the right binary for Cairo. Again, there's a couple of extra hoops that we don't have to do, but just because it's this interactive tutorial written in Rust, we need to have these extra hoops. But when you develop just for, a smart contract for Starknet or Cairo on itself, it's a little easier, but you still need to have a scarp. See, we're getting close. 7 more dependencies to go. People in the chat, how many of you actually have now your environment ready and working? Right, Carlos have a Dockerized version, so that also works. I'm just showing how to solve dependencies just by hand. Okay, it's working for Jordan at least in watch mode. That's good. Now, for me, it's also a little slower because it's a virtual machine. So even with the maximum resources that I can give it, 8 gigabytes, it's not as much as running locally on my Mac. But okay, but it finished. I was able to compile Starlings to do the Rust compilation of the project. So now I can run it in watch mode as it says here in the instructions. So you know what? I'm going to do that within VS Code. So let me just open the project in VS Code here and then open the integrated terminal. Okay, let me know how's the font size. If it should be bigger or if it's good for you. Asking me to install also the Rust Analyzer extension for VS Code, probably for syntax highlighter as well. All right. So in the README, which is preview, we can see the watch mode somewhere here. This is the command we have to run. So basically the compilation in watch mode. So every time we make a modification of the file by solving the exercises, it will pick it up. Oops, copy, paste, right? It is working apparently. So it's trying to solve intro1.cairo, right? So you see here the exercises, the side, intro. So this is the beginning and that's good. It seems to be working. Syntax highlighting seems to be working. Let me open a different file. So this is the error that I saw before. I think some people also mentioned that I saw an issue with the output. You see the syntax highlighter is not working correctly. And that's because we need to add a scarp.toml file at the root of this project. So the extension knows where to find the binary of Cairo. So I'm going to do that now. I'm just going to, next to cargo.toml, just going to create scarp.toml. And I'm going to add something like this. And this information, this is like the default scarp.toml that you can have. I'm going to paste it here. I'm just going to change this to be Starklings. It's hello world. I believe I have to, okay. Oh, it's able to pick it up on the fly. Okay, so now syntax highlighting is working well in all the exercises. So I can go back to my intro1.cairo. Okay, good. So let's take a look at the instructions. So it says, welcome to Starlings, Cairo v1. This exercise doesn't do anything yet, but it still compiles. Cairo file getting run needs to have a main function. So this file is a valid Cairo file. Other exercises will require you to write Cairo code to make the exercises file complete. Remove I am not done comment when you are ready to move to the next exercise. So basically what it's saying that every vanilla Cairo file needs to have a main function. It has to be called main. So nothing to do here, just showing you that in order to mark this exercise as completed, you only remove this comment. And when you save, you're going to say the watch mode kicks in and validate this exercise. And if it validates, it moves to the next exercise, right? And we can see the progress here. So next stop is intro2.cairo. Now it says, this exercise won't compile. Can you make it compile? So as it says in the previous exercise, we just need to create a main function. And it looks similar to Rust, right? The fn for function, and then the syntax doesn't need to have, in this case, any arguments. So I just save, and this basically just allowed the file to compile successfully. Esther is asking, you please paste the watch command here? Sure. Read the watch command. You should have it in the README. Let me see. For the README, we preview it. There, this is the command. I'm just going to copy and paste it in the chat. That's the command you need to run. Perfect. So we have completed the first section of the exercises, just the intro. Haven't done much. So the next one to solve, oh, we actually have to remove this comment. I am not done. So we actually can move forward to the next exercise. And we say, so we see now it's trying to run the exercise variables1.cairo. Okay. I haven't solved the Starknet in a while. So if I get stuck, we can just go to the documentation, to the Cairo book, and debug live. So this is one that I want to try to execute right now. Terminal. All right. Maybe compile, execute Starlings hint variables one or use hint watch command for a hint. So if you get stuck, you can actually run this command. Let me open a different terminal. Oh, command not found, Starlings. I think it's cargo compilation again. No, something's not correct here. Stop here. In any case, I can try to just resolve it on my own. So why is it failing? So if we take a look at the terminal, the message, we can see that it's complaining this line, x equals 5, right? This one here. And what is the compilation? It says invalid left-hand side of assignment. And I think that the only issue is that we need to during the watch terminal. Oh, I need to do it here? It will work. Ah, that's what I mean. Cargo run R bin. Yes. Copy. This is just to get the help. Paste the variables one. You can press help in order to see the commands. Just a pin on the watch terminal. Oh, I didn't know that. If I put here. Ah, okay, cool. And the watch terminal is actually listening for more commands here. The declaration on line 8 is missing a keyword that is needed in Cairo to get a new variable binding. So basically, to define a new variable, you have to use the keyword. And if we do that and we save, should be enough to make this file compile. Yeah, to move the font size a little smaller because it's very hard to code. Let me know if it's too small. It's just like having trouble seeing the details. Okay, so we passed this exercise, so we can just remove this comment and continue for the next step. And now it's trying to execute the file variables2.cairo. Let's open it here. All right, let's see what's happening. Obviously, you can see that the extension is telling you there's something missing here, missing tokens, expecting an expression. So it's trying to make a comparison x equal 10, but we haven't initialized the value of x. So we can just give it any value. You can just give it value, for example, if you give it 5, it should execute the second branch of the if else or the else branch. If you give it 10, it should execute the first one. So we should see x is not 10 in the terminal. And are we getting that somewhere? Yes. Debug x is not 10. So the print trait here, we need to bring it into scope. So this print method actually works and print to the terminal. Let me know if you have any questions in the chat. I'm going to remove this. So now we move on to variables 3, I imagine. Yeah. Okay, variables 3. Let's see what's happening here. Let's take a look at the hints. Okay, in this exercise, we have a variable binding that we have created on line 7 here. And we're trying to use it on line 8. But we haven't given it a value. We can print out something that isn't there. Try giving x a value. So obviously, it's trying to print something that it hasn't been initialized again. Notice that now in the exercise is explicitly defining the type to be felt 252. So this is the felt that we discussed in the slide before. So I can give just any value. Let's say 10. It should work. No, it works. But if I remove the data type, it's exactly the same because by default, if you define the data type, is felt 252. Now, as I mentioned, normally it's always a good idea to use unsigned integers or signed integers. In the case, if you're using Vanilla Cairo, I can say, for example, this is a U32, and this should compile as well. Let's remove this. I am not done. So we can proceed to variables 4. All right. So here it says, let's see. We have an assignment x equals 3, which is good. We have the let keyword. We have an initialized variable. This print should work. But then we have another assignment to the same variable. And we need to make this file compile without modifying this line. And the error says, what is the error? Cannot assign to an immutable variable. So that's an important feature of Cairo, is that all variables are immutable by default. So once we define x to be equals to 3, we can just simply change its value that we're doing here, right? It's immutable. So the way to make it mutable is to actually use a keyword called mute. So with mute, we're saying the compiler, okay, now we can actually modify X further down in the code. So let's see, let's try again. And voila, now it's actually allowing me to modify the value of that variable. Okay. And we go to variables 5. So let's see what's happening here. Let's see the error first. So it says in this line, number equals 3. So in line 10, cannot assign to an immutable variable. Nestor is asking, I thought that one was about inner scope. You mean variables 4. No, so it'll be immutable. It's actually simpler than you thought. All right, so let's see. So we cannot change this line. Notice that this suffix here, U8, right? And this is another way to make an assignment where you define the type as a literal. It will be the same as doing this. Like those two things are equivalent. I kind of prefer to do it this way. It's more explicit, but there you go. That's another way. But it says don't change this line. So I'm not going to try to cheat in any way and not change the line. And it's funny because don't rename this variable. Okay, so now we can modify this line. So we cannot use the modable keyword here as we did before. So how can we make this actually pass without renaming this variable? So what we can do is actually to create like a shadow in the variable. So I can redefine the variable, right, using the let keyword. And now from this point on, this variable is gonna shadow the previous variable with the same name. Okay, and this actually I'm not renaming the variable; it's the same name. I just reassigning it, which is different from what we did before. Okay, so it is passing. So this variable is shadowing the previous variable, and just to make it more explicit, I prefer to do it this way because it kind of drive me crazy when it looks like this. Just to show you that it works. Keep in mind that the difference is that this new variable, the data type, is different from this variable. This one is a felt 252, while this is an unsigned integer of 8 bits. I can also make it at U8. That's no problem. Okay, it works. Any question, please, you can use your chat. I'll take a look and try to help you out. Okay, variable 6. By the way, just show of hands. You can use the digital hand to raise up on Zoom. How many of you actually coding along with me? Because if many of you are coding along, I can just give you some time to solve it. And let's see, Jordan is coding along. Who else? You can raise your hand. You use the hand on Zoom so I can take a look how many of you. Paolo say he got lost. That's okay. You have the recordings. You can do it on your own later one more time. Okay, only a handful of you actually coding along, which is fine. It's fine. You don't have to code along. Just being curious. Okay, thank you for letting me know. Jordan is asking, why use shadow instead of mut, the mutable keyword? It's just because the exercise is demanding me that I cannot change this line. It's just forcing me to find a different way to solve this issue. Normally, you will just make it mutable and be done with that. Just to make it you realize that you can actually have shadow variables. Okay, back to exercise 6. Jordan is asking, yes, same question. Why use shadow instead of mutable? Just because it's forcing me to do the exercise. All right, let's take a look. You can see here that already the highlighted is telling me something wrong. It says unexpected token, expected the colon, followed by a type, and So what's happening here? Let's take a look. Wait, did I not? I forgot to remove the I am not. Let's see. Do we have more information here? What's happening? So it's complaining, obviously, the same that we see here about this assignment and about this other assignment. This is a constant. It's not a regular variable, right? So let's take a look at the hints. Let's see if we have something here. Okay, we know about variables immutability, but there is another important type of variable available, constants. Constants are always immutable, and they are declared with keyword const rather than keyword let. Constant types must also always be annotated. All right. It also pointed you to the Cairo book, which is a great resource if you get stuck. I'm just gonna open it here. Can I open it? No. So, so the Cairo book, just gonna open it here. Cairo book, target. This one here. This one is a great resource if you get stuck. I'm gonna put it in the chat and copy this here, paste. All right, back to this one. All right, so what's happening here is that when you have a constant, you have to always define the type, right? And the compiler is not going to try to infer the type or use felt as a default, as in the case of a variable. So here we can say that this is a U32, for example, whatever type. this, it's forced me to be a U8. So yeah, why not be a U8? Unsigned integer of 8. I don't like this syntax that you have this suffix. I prefer to remove it because it's already defined here. Well, let's see. If I save, will this compile? So Nestor is asking, on this one, shouldn't the compiler set the min type by default U8 on a variable if we're setting a value with the lower type U8? So it will do it for variables declared with the let keyword, but not for constants. Constants have to be defined with the type at the moment of the definition. So it is working. It's compiling, so we can just remove this comment. I'm not done, and we're done with it. Keep in mind that the homework for today is to finish Starlings. I'm just gonna do part of it today live with you, but then you're gonna have to continue on your own. Just give you a taste of how it works, and hopefully some introduction to Cairo before you get into the more complex section of the tutorial. Okay, now it's trying to run primitives types 1. So let me close this. Let me open primitive types 1. Okay, let me close this and close that one. All right, so what's happening here? Let's take a look at where the compiler is complaining. I can see squiggly lines here. Obviously, there's some let keyword with nothing attached to it. That's something, that's a bad look. So what's happening here? We have a main file, as we normally need to have on every Cairo file. Something about booleans here at the top, which is just commented out. Then we have a variable called isMorning equals to true. So this is a boolean by default. Then we use the variable. If it's true, we print this value, and then, right. So what's missing here is that we need to use this variable isEvening defined here and just give it a value. We can just give it a true as well. So we can actually get into this if clause. See, we print. Yeah, it works. We can also do just bool. Is it bool? Yeah. But it's implied if you assign a boolean variable to it as well. I can remove this. It's just comment. And I'm not done. I can remove this line. Question from Kara. Do I need to do a Starlings again to count as hacker? So if you did it in the past, just in the form for the homework, just provide a link to the repository where you solved it in the past. That's fine. Well, what I'm gonna do is just run the tests on your repository and just verify that all the tests, all the exercises actually get the tests. So you don't have to do it again. Okay, seems that it went through. So now we are in primitive types 2. So let's take a look what's happening here. It's smaller, this one. Let's see. What do we have here? So fill in the rest of the line that has code missing. No hints, no tricks, just get used to typing this. Okay, so there are some lines missing. So we have the main function. A short string is a string whose length is at most 31 characters, and therefore can fit into a single field element. Short strings are actually fields. They are not real strings. Not the single quotes that are used within short strings. Okay, so this is another example of when you actually use a felt, right, instead of an unsigned integer. It's when you have what's called short strings. And as the comment says, a short string is any string that is 31 characters or smaller. And so this variable here is actually a felt, even though it seems to be assigned a string. This is not a real string. It's just a codified version of a felt in ASCII format, right? There are also strings in Cairo that you can use, but I think this exercise is trying you to learn about short strings in particular. So what is this failing? So we have this variable assigned here. It's being mutable. There's some boolean that it's not defined anywhere. So this could be failing probably. My first initial. Finish the line. The example, what's your favorite short string? Try a letter, try a number, try a special character, try a short string. Okay, so basically it's asking you to just create another short string, and which is gonna be your character, I imagine. See, first initial, yes. Okay, so let's create it here. Your character, let's initial D. I save it. Let's see what we have. So ref argument must be a variable. Okay, I misspelled something. What am I doing different here? Oh, it needs to be mutable, probably. Yeah. I don't even remember why this ref is doing here. But it's working, it's compiling, right? So this is a short string. If we go to the Cairo book, we should be able to find about real strings, which can be longer than 31 characters. If I search here for strings, right, macro format, see, seems to be a reference to strings here somewhere. So we have the short string here in the documentation, and the string. It's gotta be here somewhere. It was added actually not long ago, just maybe like a month ago. Strings added to smart contracts and to Cairo. Anyway, you can see we have some macros that are particularly being used for strings. For example, this write macro, you can see the strings are using double quotes instead of single quotes. Okay, so now we are in removing the, I'm not done, save, and we move to the next exercise. Primitive types 3. All right. So what's happening here? Destructure the cat tuple to call print on each member. Execute Starlings hint primitive types 3 or use hint watch subcommand for hint. I'm not done. Let's see. So the issue is here because we have the variable cat, which is assigned to a tuple, but we want to access the internal members of the tuple, right? So here's where we want to actually somehow destructure into two variables, the name and the age. I forgot how is this done. I think it's something like this, name, age, simply cat, right? So basically I'm just assigning these variables in individual, like the members of the tuple are assigned to individual variables. So if I save it, that should be enough. All right, that's actually working. So this is how you can do the structuring of a tuple. So I'm gonna remove here the comment, I'm not done, and move on to the next one. The answer to all the things that you get stuck is either in the hints of the exercise or in the Cairo book. That's all you need to solve Starklings. Primitive types 4. All right, let's take a look. So it's modify the integer types to make the test pass. Learn how to convert between integer types and felts. Execute Starklings hints or use the hint watch subcommand for a hint. Okay, let's see what's happening here. We bring in some traits into scope. Then we have a function that is just adding two values of unsigned integer 8, use x and y, return the addition. To do, modify the types of this function to prevent an overflow when summing big values, right? Because if x and y could be small enough to fit in 8 bits, but maybe the addition could overflow, could be bigger than 8 bits. So, all right, convert to felt. To do, return x as a felt to 52, convert to felt. Okay. So let's see what says in the Cairo book about casting. It's casting, not casting. Huh. So in the Cairo book, you see some examples of values being casted in different types. You can see the number 10. You can turn it into an U8 by using the method try into and then unwrap, just because these operations could fail, because sometimes a fail to 52, if it's big enough, it's not going to fit into an 8 bits. So you have to do the try instead of just directly the casting. But when you go from a smaller type to a bigger type, you can directly just do the casting. So there's no need to do the get the match. Okay, so this is what we can do in this exercise. So we can go here and say, okay, I will need to use these two functions, right, to solve this issue here. So let's see. This one to convert to felt, it will be x try into, when a felt to you 8 bits into felt will always fit. So it's simply into, it will never fail. But the opposite is not true. When I go from felt to 8 bits, it could actually fail if the value is too big. So I will have to do the try into. This will return because it's a result enum. So I have to wrap. Don't put the semicolon at the end, just so it returns the value directly. So these two functions should work. And now in theory, I should be able to use them here in this function. So I'm just going to return here felt to 52. and just gonna use these functions to bring them up, big numbers. So I'm gonna say, how do I say this? Maybe convert to felt, and do it here as well. Convert to felt. So in theory, this will bring the two variables to felt to 52. We'll perform the addition and return this new variable in that type. And we have some tests here that are failing. And in particular, this test here seems to be, and this test is trying to use this function passing to, right. So it's passing to values that barely fits in 8 bits and then try to equate to 510. But 510 is actually bigger than you can fit in a single, in 8 bits. So actually I will remove this suffix. So this will actually be a felt and a U8. So it will actually make sense, the assertion. And that's it. It is working. So just to summarize, to use this function in a way that I can add two U8 bits in a way that when the addition is bigger than that, it turns into a felt. I'm using casting, typecasting. In this case, I'm using into. The method into, it will turn it into a felt, apply it to both variables, and then I change the return type to be felt 252. So the whole thing now matches. Okay. Let me know if there's a question. Okay, save this one and move on to the next exercise. All right, we'll go now to operations 1.Cairo. Operations, let me close some folders. Operations 1.Cairo. All right, let's see what's happening here. It says integer types implement basic comparison and arithmetic operators. Failed 52 operations should be avoided where possible, as they could have unwanted behavior, which I mentioned, complete overflow, underflow, and division is not usually what you would expect. So we have to implement this function, x to the power of 3 plus y minus 2. So this is the function that implements that, and we return the value. All right. The types are usize, which is U32. Also, the output is U32. And then we have some tests for this function just to make sure that it works. It actually implements this particular function here. Okay, so let's see. What if I create a variable, let's see, x3, maybe it can be x times x times x. Maybe I can do it just directly. Just multiplication, and you say that this is the variable res, the result, right? Multiply x to the power 3, then the addition, then 2, and just to make sure that it's very explicit, just group it here. Let's save it. Nestor is asking, why not use return of type U16? And you mean here, right? Or in all of this. So U size is directly translated to U32, right? The question is, why not use U32 or why not use U16? Yeah, you can. Again, it will work. Oh, I was talking about the previous exercise. Let's take a look. You mean primitive types 4, this one here? Like, why didn't we use U16 here? Is the question. You can. We can make that change as well and see what happens. I could say U16, right? But now this one has to be U16 as well, so it matches the type. But also the comparison, we have to be the values U16. Going to recompile, it passed. So yeah, you can do it that way if you want to. Okay, back to this. We actually solved the exercises. Pretty easy. We can remove this line. Okay, we've been an hour and almost 20 minutes into the call. Why don't we have a 5-minute? Let me get to 2020. So 3 minutes more, maybe one more exercise. Then we have a break. So you have a bathroom break, get some coffee, whatever. So let me solve one more exercise and then we have a break. So I can go to operations 2.Cairo. Okay, let's see what happened here. Remember last time you calculated division in Cairo 0. Now Cairo 1 has native integer types. For example, U8, U32, U56, usize, which support more operations than fails. And always watch out for overflows, example in the last test. Let's try to use them. All right, so this is the modulus. Calculate the modulus of x and y. Marshall, can we have this recording at the end, please? Yes, it's been streaming. We're streaming to YouTube, so as soon as we end, that video is going to be available in the Starknet Foundation YouTube channel. Right. So the modulus, I forgot how to do the modulus. I haven't done this in a while, so we have to take a look at the operations. Use scalar types. Where do we have it? Here, the remainder, right? So this should be let res equals x, right? And let's see, because there should be some tests here actually verifying this. So they're using 6, 2, and it should be 0 because it's an even number. So that should comply. 17, 3, we should get 2. Is that it? Yeah. Let's see. Let's save. At least for the modulus, this should work. I'm gonna comment it out other tests while I'm trying to solve one by one. Let me comment out these ones here. Just trying to isolate which ones are passing and which ones are not. We have an issue here. Identifier not found for res is because, right, these things are just here floating, doing nothing. Let me just comment it out for now. And we forgot about this test as well. We'll one by one. All right. So at least this function is working, modulus. So let's move on to the next function, the floor division. Let's uncomment this one and let's uncomment the test. See what's happening. So, okay, so because they're already unsigned integers and not fails, we can just do integer division and it should work out of the box without anything else compared to when using fails. Sometimes the result is not what you expect. X divided by X by Y. If we save, we should be able to pass the unit test. And here you have a test of how you can actually write unit tests, right? You have this test attribute that you apply to a function and then you use assert. And this is a unit test for this particular function. All right, this function floor division is working. Tests are passing, so we can move to the last function, multiplication. So let me comment this out and let's comment this one out too, one by one. And again, because it's directly an unsigned integer, it doesn't matter if it's U66, 64 or U size, it will work. So let res equals to x times y should pass. So now let's comment it out this last test, which is an interesting one, because what it's trying to do is trying to multiply two big numbers. And right, so this should overflow. Let's see, test U64. Why is this? Let's see, let's try it. Let's try to run it. See what happens. Yeah, it's passing. I guess if I try to modify the data type, it will fail. Let me see. What if I put this to be smaller, like U16 or maybe U8, like the smallest one, just to see the overflow happening. It's gonna happen now. Okay. Oh, wait a second. Right. What it's asking here is that it's saying this, when I run this test, it should panic because when you try to multiply these two numbers, the result is going to be bigger than what you can store in 64 bits, which is what's happening. So if I go back, basically by this test passing, it's basically saying, yes, it's actually panicking if you actually overflow the return variable, which is what you want, right? You don't want this to silently overflow and just wrap around and with you not even noticing that it's happening. Let's see, Nestor's asking, if we have only failed, we will need to convert all the variables first, right? And you mean for this one, for the modulo, this one here, if we had only failed, we will need to convert all the variables first. In this case, actually, you want them to be unsigned integers. You don't want them to be faileds, right? Because all the properties that we discussed before. Falco, Andrew, you have your hand up. I don't know if that's from before or you tried to ask any question, but if you have any question, just a chat, please. Okay, so this is working. Remove this comment. Okay, it's 2025 on my end. So let's have I think a 5-minute break so we can get back 20, 30, and we have 30 more minutes of Starlings. Okay, I'll just gonna mute myself. 5 minutes, get a washroom break, some coffee, and we'll be. Nestor, to answer your question, that when you should use felt, we saw one use case when you want to use short strings. Like if you want to do like my name, right? Right. Can I put it here? Anyway, I put it somewhere. Doesn't matter. Oops. If you want to have a short string, that is actually a felt. That is pretty much the only reason you would like to have fields and not use unsigned integer. But again, you have the limit that you can only have 31 characters on a single field. If you want to have a long string, then you will need to actually have a proper string, which is with the double quotes. Now, this is no longer a field, this is a string. Other than that, fields are not really that useful. Is maybe the only implementation detail left over within the language that connects to how Cairo works under the hood, which is all based on field elements. And all the math is based on field arithmetic. I'm gonna find the link to the Starknet YouTube channel, so you will know where to go to watch the recording. Give me a sec to find the link, and I'll put it there in the chat. Yeah, I put in the chat the link to a playlist on YouTube on the Starknet Foundation channel. I'm gonna add all the recordings there. So far, the playlist only have session 1, session 2, but as soon as we finish today, I'm gonna also add session 3 to the playlist. 2 more minutes and we continue. I spent so long creating slides and researching how Starknet works in the architecture that I haven't spent that much time actually coding with newer version of Cairo. So solving the Starknet slide is like a way for me to also refresh my own knowledge about language, because it changes a lot. It's a language that is evolving rapidly. I will suggest you that if you really want to keep on the edge of what's new in Cairo, you can subscribe to the repository Starkware Cairo GitHub. So this is the repository, and if you follow the releases, you will see everything that is new, and as soon as it gets published. So I'm gonna put it in the chat, and you can see some of the changes. For example, if you see releases, Cairo 2.5 just came out. What was it? 4 days ago, and one of the big things I think was the ability to use strings in a smart contract that you can actually save them. Because before we had the strings that you can create them, but you cannot store it, but now you can. And you can define visibility as well for your libraries using pub. Another big thing was, I don't know if it was the while loops also. I think it was part of this release, if I'm not mistaken. We used to have for loops. Yes. Now we also have while loops. A little easier to work with. Okay, 8:30. Let's continue solving Starklings. So let's see, it's trying to run which version? If one. Okay. We close, but if close the all. All right, this is the next exercise. Let's see what's happening. So we have this function bigger. It gets 2 numbers, returns a number. U size the same as U32. Complete this function to return the bigger number. Do not use another function call and additional variables. All right, and this is the test, the unit test to verify that it works. And basically, was saying that if I give you 10 and 8, you should return 10, right? And if I give you 32, 42, you should return 42, right? So return the bigger one, and let's see. So obviously, we need to use if else here, right? We need to compare, saying that, well, if A is bigger than B, so we have to return the bigger. So return and else we return B. And notice that I don't put the semicolon, so it's actually returning the value. See, should be all. Yeah, it's passing. It's all. So that's just your regular if else, nothing new. Right. Moving the I am not done. We go to the next one. Now we go to, I guess, if 2. All right. Step 1, make me compile. Step 2, get the bar for fuzz and default to bus test passing. So let's see the function, the tests. Foo for fizz. Okay, wait, you have 3 unit tests. Let's see. The first says that if I give you fizz, I should get back foo. So let's try to solve that one first. Foo if fizz. Okay, this one here. Notice that it actually, the type is felt 252 because we're dealing with short string. Okay, this is one example of when actually you will use a felt. Complete this function using if, else, and if and or else blocks. If fizz is fizz, return foo. If else, return bus. Let's see. So they do the first part for us. If fizz foo. All right. So then we can do else if. We compare the variable. So if this one is equal to plus, then we return currently bar, right? Another short string. Short string, the data type is felt too. And finally, for anything else, we return pass. Let's see. If fish is fish, return foo. If it's fuzz, return bar. Anything else, return pass. Okay, it should compile. Okay. So here we learn how to use else if when you have multiple conditions for your if clause. All right. Now we move on to functions one. Here, functions one. Let's see what's happening here. See the error in the console. It says function not found. So it's trying to, right, because it's been trying to use call me or to invoke call me, but this function is not defined anywhere. So we just simply need to define the function. So we can do it here. This function doesn't need to do anything. We just need to make it compile. Now, I believe you can define this anywhere, but let me just double check. What if I put it on the top? This still work? Yes, it's good. That's it. Just define the function. So make sure that it compiles. We are going now to functions two. Okay, let's see what's happening here. We had the function main, which call the function call me with the value 3. This is the function call me, which has a variable or argument called but is missing the type, right? So I can give it any type, any numeric type. I'm gonna give it you, I don't know, 64. It could be any number. I mean, 3 is small enough to fit even in 8 bits, but why make it so small? The thing is, even if you have a very small variable just using 8 bits, it just use a whole felt. So you don't gain much by trying to be, very strict about the size. U28 is a single felt still. Maybe for future versions of Cairo, it will actually make a difference in terms of performance, but for now, not really. Okay. This is passing. Functions 3 now. Let's take a look. Okay. Wait. Is this one? Why is it not working? Call me. Am I crazy? But actually, I don't know why this is not compiling. Oh, right. The function, thank you, Nestor. The function is expecting an argument, so we need to pass it here. Otherwise, that's why it's failing. And if what I read the error say wrong number of arguments, expected 1, found 0. So yes, I can find whatever. And you can see that it's actually printing the number in hex, 0xa. Okay, this is working. Moving on to functions 4. All right. Let's say this store is having a sale where if the price is an even number, you get 10 Cairo bucks off. But if it's an odd number, it's 3 Cairo bucks off. Don't worry about the function bodies themselves. We're only interested in the signatures for now. If anything, this is a good way to peek ahead to future exercises. Okay, so let's see what's happening here. Obviously, there's something missing here, as we can see. The return type is missing, which I'm gonna say that is gonna be the same U32. Don't see a reason to have a different type. What else is missing here? So let's see what's happening in the function. 51 sales price. Let's call this function. So if the sale is 51, right? If the value is even, at a 10% discount. If not a 3%. Sorry, a 10 Cairo bucks discount. Otherwise, 3 Cairo bucks discount. And this is the function. It's even using modulo 2 to get the remainder. Okay, yeah, makes sense. Save it, and that's it. Just need to define the return type to make it compile. That's all. Nestor is asking, in this case, the safest bet will be U64 or a bigger type, right? Interesting. Like, you mean like, what if I put U64 here? But if you put a different type than the one that is being passed, then you will have to do some casting, right? Yeah. So you will have to do the into method, which is a little more involved, but you can do it. Maybe easier is to just make the whole thing U64 and U64 here as well. So you have to have a, more margin of maneuver. Yeah, it's working. This is the next function actually that is complaining now, not the current one. So this is working. So let's move on to, okay, we are in quiz 1. All right, we go to the quiz. So there's a quiz after all in this session. It's just this time on the one solving it. Okay, so here we're gonna use all the things that we have learned so far about Cairo in a single exercise. So it says, Mary is buying apples. The price of an apple is calculated as follows. An apple costs 3 Cairo bucks. If Mary buys more than 40 apples, each apple only costs 2 Cairo bucks. Write a function that calculates the price of an order of apples given the quantity bought. No hints this time. Okay. So if I buy more than 40, it's 2. Anything else is 3. So you're getting a little discount for buying. Okay, so this is the function that we have to implement. Calculate the price of apples. Let's remove the comment for now. And let's see the tests. Let's see. All right. So first of all, what's being passed is how many apples Mary is buying. So let's call this amount. The type, let's give it U64. And this also is going to return a value. I'm just going to call it also U64. Now I have to do some if else, right? Just to see how many apples she's buying. So if she's buying more than, how much was it? 40, then the cost is two Cairo bucks, right? So we'll have to return 40 times 2. But if she's buying any other amount, 40 or less, it's actually, oh, sorry, this is amount. It will be then amount times 3, a little bit more expensive. Doesn't like something here. What is it? Doesn't like? Could be the types. When expected return type. Oh, right. I need to remove the colon, otherwise it doesn't return anything. Yep, it's passing. Maybe a way to make it a little nicer. Maybe I can do something like, for example, let price. Let's say the default price is 3. Just a different way to solve this. I can make this mutable, and I can say if you're buying more than 40, so modify. You say now price is equal to 2. I can remove the else clause and simply say return amount times price. This should also work. Yeah, there's a different way just to try to force to use a mutable variable. That is the quiz. Any questions you have so far? Remove the I am not done. Okay, next we're going to loops, and I forgot all about loops in Cairo. So let's hope I remember. Let's see what's happening here. Okay, so we have a single test, and this test has a certain amount of gas because we have a counter equals 0 that is mutable. And then what's happening is that as soon as the loop starts, this is the syntax for the loop, it breaks, it gets out. So this never actually executed. So this loop is doing nothing. So what are we trying to do here? We're trying to get the counter to 10, okay? So basically, first of all, we need to move this after, yes. And we can say that after we increment, say, well, counter, if it is 10, I need the parentheses, right? Then we can break, right? We can stop the loop. Otherwise, keep the loop going. Makes sense, right? And yes, it's passing. Interesting here is that it's using this available gas attribute as well, just because loops, if you don't do it correctly, you can actually get an infinite loop, and this is trying to prevent that from happening. So if I remove this line here, right? This is an infinite loop. It should stop when I get to this amount of gas. I mean, it will fail because counter at that point will be a huge. Variable not drop. Oh, actually, so we actually need the break then. But anyway, that's the point of having this available gas. Just in case you get into the situation that you get an infinite loop. What if I put the number extremely big one? Right. It fails out of gas. That's what I was trying to force, right? To get to this condition. All good. Good. Back to 10. This is more relevant when you actually thinking about smart contracts than just, okay, remove this comment. I'm not done. And go to the next exercise, which is loops 2. Let's see what's happening now. Okay, we have again the same counter, the same, it's a test, same amount of maximum gas. We have our loop. Now our loop actually returns a value because you see the assignment. And when the counter gets to 5, we're supposed to return the value because that's what the assertion. is verifying here. So with the to-do saying return the value from the loop, and based on what I saw before, this seems to be using the same break, and the parenthesis is to return value, I would imagine. So when it gets to 5, the loop stops, returns the counter gets assigned to the variable result, and then we compare result to the number 5, and it's working. Okay, next exercise is, where are we? Enums. Okay, it's an interesting topic. Enums. Enums. Number 1. Okay. All right. So we have an enum called message, and the to-do is to define a few types of messages as used below. And you can see how is this being used, right? So our message enum has 4 variants: quit, echo, move, and change color. And there's an implementation of a trait. Oh, this is mostly just to print the value, right? This is not really relevant for us, apparently. Just to make a compile, let's see what is complaining here. It says in the compilers, right? Enum exercise create message has no variant quit, right? So because we're trying to use it, but it's not defined. And I kind of forgot how to do this, so we can just get back to the book and take a look at enums here, and we can see some examples, right? So it's a simple enum, northeast, southwest, and commas. So that's all we need. That's how you use it. All right, simple enough. So I can just go and say quit, comma, echo, comma, move, comma, change color. See, should be all that is needed. Should compile. Yeah, it's working. Very simple. I might have to solve maybe 2 more exercises, and then, there's a lot of exercises for you to solve as part of your homework. Enums2.cairo. Let's take a look at this one. So we have the enum message again coming back. Now here we have seeing quit, echo, move, change color, but the difference is that now the enums actually have a value associated with this. Echo, for example, has a short string associated. Move has a tuple of 2 values, and change color has a tuple of 3 values. So interesting. So let's go back to the book to see how can we actually define that. And sure enough, we have an example almost the same as Starklings, so almost like inspired by it. So when you define the variants, to define also, if you want, the type of each of the variants. So coming back to the example, we can see that, first of all, width doesn't have a type, so that's fine, right? It's just the enum. But echo is actually a short string, and we know that a short string is nothing more than a felt. Then we have move, and we can see that move actually is expecting to be passed a tuple of 2 values. So 10 and 30, I don't know, I will say that this is U32. Like, it could be any number, but big enough to have 10 and 30. Then finally we have change color, which is also a tuple, but it looks like an RGB. And an RGB, one of each of these values is 8 bits. So this actually makes sense to have it on some integer of 8. Sorry, right? Okay, let's save and see what happens. It is working. It is working. Okay, good. So I'm not done. Okay, I'm gonna solve the last enum, and then we finish for today. Recall that you're gonna get the feedback form for you to give me feedback and about the session. Then the last enum exercise. Let's say what's happening here. Address all the to-dos to make the tests pass. So we have again the same enum message, but let's see what are the variants. Let's see what is being used. Oh, this is pretty big. Create a match expression to process the different message variants. So this is asking us to use not only to define the enum, but also to use it with a match syntax. So let's see. Where is message being used? Change color, quit, echo, move position, process. Right. So this is a trait, the implementation of a trait. And this trait applies over state, which is this struct right here. We haven't looked at struct yet. And it's been passed a new color, then quit. So let's see, let's start from this area here. So we get, obviously the self is the struct itself, but then we have the message enum. And I guess depending of the variant of the message enum, we will have to call one of these methods, either change color, quit, echo, or move position. Okay, so I guess let's take a look at how this match will work. Pattern matching, we can see some example here, right? And you have the arms and what to do in case of each one of the matches, and the keyword is match. So let's give it a try here. So we'll do match message, right? Open the curly braces, and now I define all the different variants that I can have. So it seems to me like we're gonna have one for each. So I'm gonna start with the simplest one, which I think is quit, because it doesn't have any. So if the value is similar to message quit, something has to happen, right? The thing is, we need to define the variant here as well. So let's go and define quit. So if that's the case, we're gonna call is self quit. Is that how it works? I'll take a look at the test. Oh, okay. The test makes more clearly the types of the variant for the enum. So we have 4 variants, similar to 4, basically. The only difference is that now we have a move variant that is a struct. So let me define the enum first. I'm just gonna copy this. Well, quit, move, echo, change color. Quit, echo, move, change color. And now the type of each one of them, I can see that obviously I know quit. Echo is a short string. So that's well, it's 52. Move is the struct that we have defined. No, oh, I think it's a point. See, yeah, it's a point. That's a data type. And change color is the tuple that we had before. It's an RGB. Okay, we have now the variants, and because now we have the variants, I can define them, all the match statements. I don't know yet exactly what they're gonna do, all of them. I'm just gonna define the match. So message dot echo, and looking at these functions, they're actually being expected to be passed what's in store inside the enum. And if I see the documentation, it's being passed like this. All right. So echo value, and the value will be available here. So I guess I can do self dot echo, and pass the value, right? Then I go to the next variant, which is what's the next one? Can do move. Maybe change color is easier for now. Change color, and we have 3 values x, y, z. But it's a tuple. But let's see what's expecting. The change color is expecting the tuple. What if I just pass it as just x, like give me the whole tuple like this, and then I call it self dot change color, and I pass x. Right, could be RGB as well. Yeah, that makes more sense. RGB, more descriptive. And finally, I have the move one, message move, and I get the point, and then I'm gonna call self dot move position. That's the name of the function, and I pass the point. Is this enough? Oops. All right. It's complaining, saying that variance must be the same order as enum declaration. Interesting, because I thought this was solved in the last scarp, the last version of the scarp. But anyway, I'm gonna try to solve this here. I'm just saying that these branches should be in the same order as we define it here. So quit, echo, move, change color. But I believe in the latest version of Cairo, that is actually solved. It doesn't matter the order. I don't know why it's not picking up the latest version. Let's try again. And it's passing. Right, that is the last exercise for today that I'm doing live. Now it's up to you. Please solve the Starklings on your own. Remember to publish it to GitHub as a public repository, and use the form to register your solved version of Starklings. If you did it in the past, just provide that one as well. And this is going to be the homework for session 3 and session 4, because as you can see, there's also exercises for Starknet that so far we haven't covered that. We're gonna cover Starknet session 4. So that's all from me. Thank you very much.